We want to solve the given differential equation using separation of variables. So once we know the equation is solvable using separation of variables, our goal is to rewrite this in this form here, meaning the y terms and dy are on one side of the equation and x and dx are on the other. If we can write the equation in this form, then we can integrate both sides of the equation and then hopefully solve for y. So for the first step, let's go ahead and write this in differential form or multiply both sides of the equation by dx. So we'd have dy equals x divided by y times the quantity x squared plus 1 dx. And now looking at the right side of this equation, notice we have x's and dx except for this one variable y, which is in the denominator. So now if we multiply both sides of the equation by y, or if it's helpful, y over 1, notice how this would simplify out with this y here. So now we have y dy equals x divided by the quantity x squared plus 1 dx. All the y's are on the left, all the x's are on the right, and now we can integrate both sides of the equation. Integrate y to the first. With respect to y, we'd have y to the square divided by 2, applying the power rule, or just 1/2 y squared. We would have a constant of integration, but we'll go ahead and put that on the right side since there'll be a constant on the right as well. But to integrate this, we will have to apply u substitution. We're going to let u equal the denominator. So if we let u equal x squared plus 1, then differential u would be equal to 2x dx. But notice how our integrand only contains x dx if we're letting x squared plus 1 equal u. So let's go ahead and divide both sides of this equation here by 2. So we have 1/2 differential u is equal to x dx, which is now a perfect fit for our integral. So if we write this in terms of u, we'd have 1/2 times the integral of 1 over u du, which would be 1/2 times the natural log of u, or 1/2 times the natural log of u is actually x squared plus 1, plus our constant of integration, we'll call it c sub 1. Now we do want to solve this equation for y, so let's go ahead and eliminate these fractions by multiplying both sides of the equation by 2. So on the left side, we just have y squared equals, here we have to distribute, so we'd have natural log of x squared plus 1, and then we'd have plus 2 times c sub 1. We'll go ahead and let c equal 2 times c sub 1. Remember, 2 times c sub 1 is just another constant. And now for the last step, we'll square root both sides of the equation. When we do this, remember, y could be positive or negative. So if we take the square root of both sides of the equation, we're going to have y equals plus or minus the square root of natural log of the quantity x squared plus 1 plus some constant. Okay, I hope you found this example helpful. Next, we'll take a look at a differential equation involving trig functions.